So this is a set of this is an old slideshow that I made for another textbook, but it certainly applies. And some of this is stuff you already saw last week. So I'm sorry about it to repeat. But basically with what correlation measures, it's a way to look at how strong your linear relationship is between two quantitative variables. So let's see. So some things that a couple of people have helped just recently. We're still a little confused with X versus Y. Remember, X, your explanatory variable or your X variable goes on your horizontal axis. Your response variable goes on your Y-axis, your vertical axis. And in this situation, they're trying to compare GPA versus IQ. So so it looks like my GPA, there's a positive association between these two variables. It's moderately strong. It's somewhat linear, though this down here is really strange. So a lot of variation going on here. It's not, R is not going to be very strong here. So that's what I'm seeing here, I guess. Let's see, what else do I want to say? So yeah, so the closer the points are to a straight line, the stronger the relationship, the linear relationship. I mean, you could have a curved linear relationship, curvy linear relationship where it's curved and it's just really strong, but it's not linear. And R measures linear, and Moore is the name of the author for the textbook I made this for. We do not need to worry about calculating R. I'm not going to make you do that manually. Yeah, it's right here, so you're not going to have to, but you can use a spreadsheet for it or applet. Okay, so some things to keep in mind about correlation. The stronger the positive relationship is, well, maybe I'll do that in the next slide. So what I usually do when I'm trying to imagine what R is, correlation is for a set of data for a scatter plot, I try to put an oval around it. And if that oval goes up to the right, I know it's a positive association, and R will be positive. And when it goes down on to the right, it's going to be a negative relationship. And if you think about slope of a line, I mean, because that's where we're kind of going with this. Right? This is a positive slope line, so R will be positive. If R is a negative slope line, R will be negative. I mean, if data has a negative slope, it goes down. R is negative. Notice it's negative. These are this equally strong, or just about equally strong. Okay. Let me clear this. Let's see, what's the next slide going to be? Here we go. Yeah, here's where I talked about this. So R can be between -1 and +1. If I throw, and I very well could do this, throw a test question at you, and I say R is equal to -1.2, the answer is going to be you made an arithmetic error in calculating R, because R can be a perfect negative association is like what I said right here. If it's on if it's all the points follow a straight line and there's a negative slope, R is going to be -1. If it's a positive slope going up to the right and they all follow a line, R will be +1. And if there's no correlation, I don't know if this link works. Let me see if this link works. Oh, it does. You see how this these points are all over the place, and if you try to put an oval around it, it's more of a circle. R is pretty weak. See how it's close to 0? 0.026 is pretty close to 0. Here's a perfect positive association. There's a perfect negative association, or pretty close to negative, and there's some variations in between. Now, in Moodle, I don't know if that link takes you to the right place, so I'm not going to click on it. But in Moodle, let's see if I can go back there. I gave you this link, and what this applet does is it throws 4 scatter plots at you, and you have to get some experience guessing. Now, if you want to compare to, what was it, DLE, what did I say it was? DLE 15. This is a way that we can compare all the people that have used this in my classes. We can compare how I'm going to do, we can amass the, notice it's from Oxbow, sorry about that. But I teach the same course at Oxbow, so here, let's get some practice guessing R. So these are 4 correlation coefficients that they calculated for us based on the data. For this one, I'm seeing no clear trend. I mean, it's not going up to the left or down, up to the right or down to the right. It's pretty much in the middle. So this is going to be close to 0. So I'm going to look at which of these numbers is the closest to 0. I guess it's negative 0.23. Okay, I guess I can imagine there's a negative association here, not much of one. This is clearly negative and pretty strong. I mean, it's not too bad, and this is positive. So let's go with the strongest negative and the strongest positive. So I think this is the negative 0.75. It's a negative association, and it's the highest value of R. This is a positive association, and that's the highest positive value of R, so I'm going to select that. And then since there's only one left, I think this shows a little more trend than this one does, so that kind of makes sense that that's going to be the negative 0.39. Okay, let's check and see how I did. Oh, I did them right. I don't always do that. Oops, let me quit. Don't want to install iTunes. Okay, I could do new plots. I'll just do one more here. Pretty strong positive, probably the 0.9. That I'm seeing a negative relationship, and these other two look kind of positive to me if I picture the ovals. So I think this is going to be the negative one. And then I think this looks weaker than this one. We'll find out. I don't always get these right. So I'm going to do, make this be the 0.44, make this be the 0.48. Not a lot of difference, and sometimes it's hard to see. Let's see how I did. I guessed correctly. Okay, so that's to get some practice with this. I'm going to ask you to do this on a quiz. So now let's go back to my slideshow here. What else do I have going on here? We talked about R, we talked about that, I showed you this slide. Okay, outliers, it's a good little discussion of outliers. Not, I don't know if those really, I guess they're outliers. I guess they kind of mess it up. Typically what happens, the further away from the center, the stronger the outlier is. So you see how that value, and it's usually in an x direction. If I were to have a point, this point here is pulling the correlation down. If I had a point way out here, way away from the data, that's going to strengthen the correlation, and that is an outlier. I mean, it is far away from the data, but it follows the trend. So this would be called an influential point, because this is going to strengthen the correlation, whereas that point is an outlier. That weakens the correlation. Okay, so it's not a big idea, other than maybe looking at your data to switch some things around. Let's see, what else do I have? Oh, here's a curvilinear I wanted to show you. This has a pretty strong association, but it's not linear. Okay, it's not following a nice straight line. So R was really weak, even though that's a fairly strong relationship. In other courses, and on your calculator even, you can, or a spreadsheet, you can talk about R squared with a nonlinear relationship. But with lines, we don't worry too much. We don't, I mean, we're just concerned in this course about linear relationships. We're not going to go beyond that. Okay, so there's that. What else do I have here? Here we go. Pretty strong relationship, but Y never changes, so that would have a correlation of 0. Okay, so horizontal, not much trend. And then if we were to do some more work with that, you'd see that, yeah, these horizontal lines, points to horizontal lines that go through them aren't really much of a relationship, because it doesn't matter what X is, Y is always the same number. Okay, so that's scatterplots, correlation. Maybe I'll stop this video and continue with another one.